So as I was getting ready to say, there are actually many reasons why we would want to know how to factor. In this class, we only look at one. But when you take intermediate algebra, you'll see several more uses for factoring. And when you take, if you take college algebra or gen ed math, you'll see even more reasons for why we want to know how to factor. But in this class, we only look at one. So to set this lesson up, I want us to go backwards first. I want us to go back to chapter 2. In chapter 2, we were solving equations like this. 2x plus 3 is equal to 12. Now, that type of equation, when we covered it in chapter 2, we called a linear equation. And we said at that time that a linear equation was first degree. That meant that the largest power on our x was 1, the one that we don't usually write. Now I want you to know what I just said. On this next test, I'm going to give you some equations, and you're going to have to classify whether they're linear or the second type of equation we're going to look at today, which is quadratic. And so any equation that's just got an x to the first is going to be linear. Okay, well here's how we solved those equations. Remember, the big picture idea was x is on one side of the equation and constants on the other. So we approached this problem in this fashion. We said, well, the x's are already on the left side of the equation, so we'll put our constants on the right. So to get the constants on the right, we'll subtract 3 from both sides. How to get those 3 and negative 3 to cancel. So we'll have 2x equal to 9. How would I finish that equation?
Divide both sides by 2.
That's right. Divide both sides by 2. And x is equal to 9/2. Okay, so the strategy for solving a linear equation is get the x's on one side, get the constants on the other. No big deal, we did a lot of that. Now, today, we're going to be doing the same type of thing from a big picture perspective. We're still solving equations, but the equations that we solve today are not going to be linear, they're going to be quadratic. You say, what's a quadratic equation? It's an equation that looks like this. In a few minutes, we're going to solve this equation. X squared minus 5x is equal to negative 6. So look at this equation that I just put up here, this one, and compare it to the one we started with up here. What's the difference between the two equations?
On the linear, the highest factor is always going to be a 1, and then on the other one, something's going to be bigger.
There you go.
The power's going to be bigger than 1.
Yeah, it's not only going to be bigger than 1, but in this case it's going to be 2. So today, all our equations, the biggest power is going to be 2, and when you have that, that's called a quadratic equation. So on this test, a week from today, the first thing, when I give you equations, I'm going to say, tell me whether this is a linear or quadratic equation. If it's just got an x in it with no square, you're going to say that it's linear, and you're going to solve it like we did up here. If it's got an x squared in it, you're going to say it's quadratic, and you're going to solve it like we learned today. So our job is to learn how to, one way to learn how to solve an equation like this one today. That's what we're after. Okay, so how do we do that? Well, first we got to give ourselves some tools to work with. So we're going to move this equation off the screen here, and we'll come back to it later. So to give ourselves some tools to work with, the first tool we're going to need is something called the zero factor property. You already know what the zero factor property says, you just don't realize that you do. Let me prove that to you. The zero factor property looks like this. It says if A times B is equal to 0, then one of two things has to be true. What do you think we're going to put? What one of two things has to be true?
Either A or B has to be 0.
That's right. You cannot multiply two things and get 0 unless one of them 0. That's the only way it can happen. So if A times B is equal to 0, that means A is equal to 0, or B is equal to 0, or they're both equal to 0. If either one of them are equal to 0, then A times B is going to be equal to 0. So that's not a difficult concept. Now let me show you how we're going to apply the zero factor property today. We're going to apply the zero factor property so that we can solve equations like this. The quantity x plus 3 times the quantity 2x minus 1 is equal to 0. So, think of your x plus 3 as your A, and think of your 2x minus 1 as your B. And we just said up here, if A times B is equal to 0, which is what I have here, then that's true if either A is 0 or B is 0. Which means this equation is going to be true if either x plus 3 is 0 or 2x minus 1 is 0. So to solve this, that's exactly what we're going to do. We're going to take each of those factors, set them equal to 0, and solve. So we'll let x plus 3 be equal to 0, and we'll let 2x minus 1 be equal to 0. Okay, so we're going to solve each one of those now. Now, if x plus 3 is equal to 0, to get the x by itself, I'd have to subtract 3 from both sides. Get those to cancel on the left. I'd get x equal to negative 3. If 2x minus 1 was equal to 0, I could add 1 to both sides. Get negative 1 and 1 to cancel. So 2x would equal 1. And if I divided both of those by 2 then, get the 2's to cancel, x would also be equal to a half. So there's an equation that's different than a lot of them we've had in this class because it's got two solutions, not just one. If you want to see how they are solutions, you could put them back in. If you put negative 3 in here for x, you'd have negative 3 plus 3, that'd give you a 0. Over here, 2 times negative 3 is negative 6 minus 1 is negative 7. And 0 times negative 7 is 0. If you put the 1/2 in, a half plus 3 here would be 3.5. Over here, 2 times a half is 1. 1 minus 1 is 0. 3.5 times 0 is 0. So they do both work. Now let's do one more of those just to make sure that we've got the hang of that kind of problem. So let's say I had y times 3y minus 4 is equal to 0. Well, think of y as your A and 3y minus 4 as your B. So that'd mean either y is equal to 0 Or 3y minus 4 is equal to 0. Y equals 0 is already solved. So we're done with it. If 3y minus 4 is equal to 0, I could add 4. Those cancel, so I have 3y equal to 4. And divide by 3. And I'd have y equal to 4/3. So what does that mean for us right now? It means if I can get an equation to look like this right here, then I can solve it. If I can get it to look like something times something equal to 0, then I can solve it. Okay, now that's what we're going to try to do with this problem here. X squared minus 5x equal to negative 6. We're going to try to get that to be something times something is equal to 0. And then go from there. Okay, we're going to try to change it from an equation that looks like this into an equation that looks like this. Well, how do we do that? Well, we do that with 3 pretty simple steps. We'll just call this part of our notes solving quadratic equations by factoring. Well, the first thing we got to have to do that is that 0 that I keep talking about. We got to have a 0 on one side of the equation. So step 1, set the equation equal to 0. So whatever you got to do to get a 0 on one side, do that. Step 2. Now, what we want is to get something times something equal to 0. Well, the process of getting a polynomial to look like something times something is exactly what we've been doing this entire chapter. That is factoring. So step 2 is factor. Okay, after those 2 steps, we'll have a problem that looks like those other problems that we worked today. So then step 3 will solve by setting each factor equal to 0, just like we did on the last 2 problems. Well, let's go see what kind of damage we can do on this equation now. Maybe we use a little different color ink, show that we're changing it up a little bit. Okay, so this is a quadratic equation. So how are we going to solve it? Well, step 1 over there said to get a 0 on one side. Class, how could I get a 0 over here? How do you get rid of a negative 6? You add 6, that's right. So we're going to add 6 on the right. But if we add 6 on the right, we got to add 6 on the left. Okay, now, when you write this polynomial on the left now, this one over here, make sure you put it in descending order. That'll make it a lot easier to factor. So what do we have now? We've got x squared minus 5x plus 6. We can't add any of those because they're not like terms. And on the right side now, negative 6 and plus 6 cancel, and we get a 0. So step 1 is done. We got a 0 on the right side of the equation. Okay. Step 2 said to factor. So now we're going to factor x squared minus 5x plus 6. So now we go through our guidelines for factoring that we've been reviewing over and over again. So the first question is, do I have a common factor? So, ladies and gentlemen, in x squared minus 5x plus 6, do you see a common factor? I don't either. Yeah, x squared's got a 1 on it, so that doesn't really help me. Okay, it's got 3 terms, 1, 2, 3, so I know I'm going to use the AC method. In this case, I can use the shortcut because I got a 1 on the squared term. So 1 times 6 is 6. The square root of 6 is 2 point stuff. So we ask if 2 goes into 6, and it does 3 times. So we'll have either 2 and 3 or negative 2 and negative 3. And negative 2 and negative 3 do add up to negative 5. So how does it factor? X minus 2, x minus 3. Alright, and now step 2 is done. And not only is it done, but do you see that we've made this equation look like those others? So we can take each factor, set it equal to 0, and solve to finish this problem off. So let's do that. So we'll let x minus 2 be equal to 0. We'll let x minus 3 be equal to 0, and we'll solve each of those. On the left side over here, I'm going to add 2 to get the x by itself. And I'll have x equal to 2. There's one solution. And over here, we'll add 3 to both sides. It's negative 3 and 3 to cancel. And we'll get x equal to 3. And there's the other solution. So x equals 2, x equals 3. Questions? Alright, let's look at a few more and see what other kind of situations we can get into then. Four p squared plus 40 is equal to 26p. Admire, is this a linear equation or a quadratic equation, and how do you know?
It's a quadratic, and because it has a square.
Very good. That's exactly why. Okay, and if it's a quadratic equation, the first thing we want to do is get a 0 on one side.
So subtract negative 26p.
There you go. Subtract 26p from both sides. And when you write the left side, make sure you put it in descending order. So we're going to put the 4p squared first, then the minus 26p, then the plus 40. And on the right side, it all cancels, so we get our 0 that we need. All right, now let's factor. So we should ask if there's a common factor in 4, 26, and 40. And there is. Now 4 won't go into 26, so it's not 4, but 2 will go into all three of those. So let's factor a 2 out. 2 out of 4p squared leaves 2p squared. 2 out of 26p leaves 13p. 2 out of 40 leaves 20. Now, we need to look at what's inside here. It has 3 terms. So if it factors, it'll factor by the AC method. So that 2, I can't do anything with. I can't use the shortcut because I got a 2 on the p squared. So we have to rewrite it. Okay, so we've rewritten it as 4 terms, and now we got to take 2 times 20 and get 40, and this is the same old song and dance we've done a trillion times now. If you square root 40, you'll get 6 point stuff. 6 doesn't go into 40, so we'll check 5. 5 goes into 48 times. So either 5 and 8, -5 and -8. And that's the one that adds up to -13. So you go -5p minus 8p. Okay, now look, here's how sophisticated we're getting now. See, we're so long here that we got to move. Oh, crud. All right, well, with our 4 terms now, we'll do grouping like we always do. Oops. Put a plus in the middle. What I was saying was our problem, you're getting quite a bit more sophisticated than where we started the semester because our problems are getting really long. I mean, we're going to have to move this problem up on the screen here to be able to finish it. Okay, so out of 2p squared and 5p, we could take out a p. And that'll leave us with 2p minus 5. To be left with a plus 2p minus 5 out of the last 2 terms, we would need to take out -4. There's our 2p minus 5. So to get it factored, we're going to have a factor of 2, a factor of 2p minus 5, and a factor of p minus 4. Okay, so we got it factored. Step 2's done. Now let's take each factor and set it equal to 0 and solve. So this problem's a little bit different than the last one that we had because we have now 1, 2, 3 factors. So normally we would set all of them equal to 0 and solve, but in this case, if you set the first one equal to 0, that would just give you 2 equal to 0, and we know 2 is not equal to 0. So just ignore that one. Or 2p minus 5 equals 0, or p minus 4 equals 0. And now we're on the home stretch. So here we can add 5. Get those to cancel, so 2p will equal 5. Dividing by 2 gives p equal to 5/2. And then over here we'll add 4. Those to cancel, and p will equal 4. So if you just want to box those answers in, that's fine. That works for me. Sometimes you see those answers written as a solution set. They'll put them in these set brackets and put 5/2, comma 4. And if you check the back of your book for the answer, it may have it written this way. So just know that. So there you go. Rock on. That's, look at that. That's a pretty long problem there, class. Moving up in the world. Okay, well, I want to look at one more with you, just to make sure we're good with everything that can happen. So let's look at this one. 6z cubed minus 6z is equal to 0. Now, when you look at this problem, you might say, hey, Mr. Black, that's not linear, and it's not quadratic, because a quadratic has a biggest power of 2. And you would be making a good point if you thought that way. But this is a problem that we can use quadratic techniques to get solved. So let's do what we've done with our quadratic equations and see if we can get this one solved. So the first thing we need is a 0 on one side, and we got that. The second thing we need to do is factor. And on this problem, there is a common factor in both of those terms. We could factor out a 6z. 6z out of 6z cubed leaves z squared. 6z factored out of 6z leaves 1. Okay, now we need to try to factor this stuff in here. Well, it's got two terms. So the first question I should ask when I have two terms is it the difference of squares? Class, I'm asking you, is z squared minus 1 the difference of squares?
No,
Are you sure?
maybe not.
Well, when I'm looking at z squared, I'm thinking I could call that z times z. And when I'm looking at 1, couldn't I call that 1 times 1?
Yeah,
And put a minus in one and a plus in the other? So it actually was the difference of squares. Okay, so we got it factored now. And this time we have 1, 2, 3, 4 factors. So we'll set all 4 of those factors equal to 0 and solve. Well, 6 cannot equal 0, so we'll ignore that. But z can equal 0, so there's one solution. Z minus 1 could equal 0, we'll solve that and get another solution. And z plus 1 could equal 0, so we'll solve that and get another solution. This first one's already done. That's kind of nice. And on the second one, we just add 1 to both sides. So z will equal 1. And on the last one, we'll subtract 1 from both sides. Get those to cancel, and z will equal negative 1. So here's an equation with 3 different solutions, 0, 1, and negative 1. Okay, so that's the kind of stuff that you're going to have to do out of Chapter 6, Section 5. Let me see if we can run you down an assignment here. So, your assignment will be on page 398. You can start with number 19 and work down the column. We've talked about how to work down the column before until you get to number 55. Now 53 and 55 have a little bit more to do than the problems we did. There's a little bit of multiplying you got to do first. So if you have trouble on those, you can ask next time. I think you can get them, but if you have trouble, just ask next time. And that'll put a wrap on section 5.